like to know about a rectangular waveguide analysis. So by derivation we can see the analysis of rectangular waveguide. In order to analyze the rectangular waveguide, so we must consider the wave equations of electromagnetic wave. So this is the wave equation. So del square E is equals to mu epsilon dou square E by dou t square. So similarly this is for the electric field, and we write for the magnetic field which is similar to electric field. So del square H is equals to mu epsilon dou square H by dou t square. Okay, so from the first electric field equation, so we can written as in terms of del square as in terms of Cartesian coordinate system. So the E is present along a Z direction. So let Ez is equals to E z naught e to the power of j e to the power of minus gamma z. Okay, so now we can see this e to the power of value, this Ez value is also varying with respect to omega. So we can represent in terms of time variation, so it will be represented with e power of j omega t. Now this Ez can be written, so if I differentiate with respect to t, this is the first equation, so I am differentiating with respect to t. So dou Ez by dou t value is equals to, so in terms of with respect to t we are deriving, so j omega will get here, so remaining part is continued here, Ez naught e to the power of minus gamma z e to the power of j omega t. Okay, so now you can say this j omega multiplied with this is nothing but a Ez. So dou Ez by dou t is nothing but a j omega by j omega e to the power of z. Okay, so in this way you can say, so if you again differentiate this equation, again differentiate first equation, so you'll get a dou square E by dou t square is equals to j omega multiplied with j omega Ez, you will get it. Okay, so that so j square is nothing but minus 1 minus omega square Ez. Okay, so this is the value of dou Ez by dou t square value. So from comparing this equation, dou square by dou t square is nothing but minus omega square. Okay, so from this equation you can observe this. So from this equation you can observe that it implies, so dou by dou t is nothing but a j omega. Okay, now equate first equation. So from equation 1 is differentiated with respect to z, so then the equation comes as, so first equation is differentiated with respect to z, so dou E by z, so e to the power of, so minus gamma E z naught e to the power of z naught e to the power of j omega t e to the power of minus gamma z. Okay, have you understand about this? So here you will get a e to the power of with respect to your differentiating with respect to z, so you will get gamma. Okay, so now we can compare this with that equation, so we can written as, so dou Ez by dou z is nothing but a minus gamma Ez. Okay, so this from this equation you can say that dou by dou z is nothing but a gamma minus gamma value. Okay, differentiation, again differentiate equation 1 with respect to z, so that you will get again dou square Ez by dou t square, dou z square, which is equals to, so minus gamma multiplied with minus gamma Ez naught e to the power of j omega t e to the power of minus gamma z. So minus gamma, so dou square Ez by dou z square, which equals to, so gamma into gamma, gamma square, minus into minus plus, so gamma square Ez, you can say this is a Ez. Okay, so you can say dou square Ez by dou z square is equals to gamma square Ez. Okay, so this is another equation. So by comparing this equation, so you can say dou square by dou z square is nothing but a gamma square from this equation. So this is the equation number 4 and this is the equation number 5. Okay, now from wave equation, from electromagnetic wave equation, from wave equation, which is nothing but a del square E is equals to mu epsilon dou square E by dou t square. So that is the equation. So according to that equation, so now we talking about a z Ez equation. So substitute this in the place of zz and here also Ez. So this del square can be written as dou square by dou x square Ez plus dou square by dou y square in terms of Cartesian coordinate system. So this can be written as, so Ez plus dou square by dou z square Ez is equals to mu epsilon dou square E by dou t square. Okay, as you got the expression for a dou square by dou t square value is minus omega from this equation 3. So you should substitute the dou square by dou t square in this particular equation. Okay, and dou square by dou z square, we got a gamma square. So these equation, from this equation 5 and equation 3, you can substitute in this particular equation the values. Okay, so after substitution the equation comes like this. So dou square E x by z by dou x square plus dou square by dou y square Ez plus, so this can be written as gamma square Ez is equals to mu epsilon, so dou by dou t square can be written as minus omega square Ez. Okay, so now taking this as other side, so this term as other side, so you can written dou square Ez by dou x square plus dou square Ez by dou y square is equals to, so gamma square Ez plus mu epsilon, so this can be written as minus here minus omega square Ez. Okay, so here take common as Ez in this particular term, so you can gamma square omega square mu epsilon. Okay, this is the value. So this is nothing but a dou square Ez by dou x square plus dou square Ez by dou y square value. Okay, so this can be treated in terms of constant. So as this is a constant, so you can written as dou square by gamma square omega square mu is equals to h square. Okay, so this can be replaced with h square. So the equation is changed to dou square Ez. You can see from this particular equation, so if this term is moved to this side, so this is changed to negative sign. So if we take a negative sign as common, so you'll get a gamma, so take Ez as common in this particular equation, so you'll get Ez minus Ez common off, so multiplication of gamma square plus omega square mu epsilon, so this can be moved to this side, so it will be moved to, so gamma square plus omega square mu epsilon is nothing but a h square, so you can move to this side, so it can be written as, so dou square Ez by dou x square plus dou square Ez by dou y square plus Ez multiplication of h square is equals to 0. So this is the another wave equation obtained from this wave equation. Okay, so the obtained wave equation in terms of h as like this, so dou square Ez by dou x square plus dou square Ez by dou y square plus h square Ez is equals to 0. So similarly, if you can written in terms of h, so that can be written as dou square hz by dou x square plus dou square hz by dou y square plus h square hz is equals to 0. Okay, so now from Maxwell's second equation, from if the Maxwell's second equation is nothing but curl of E bar, this is in the point form. Okay, curl of E bar is equals to minus dou p bar by dou t, so which is equals to, if you substitute b is equals to mu h in this particular equation, so I'll get minus dou by dou t of mu h. So this dou by dou t can be written as omega, so we have already seen that. Okay, so dou by dou t can be written as j omega, so minus j omega, so dou by dou t is minus j omega mu h, so this is the value, curl of E bar is equals to minus j omega mu h. Okay, now this h can be expressed in terms of Cartesian coordinate system as h bar is equals to hx ax plus hy ay plus hz az. Okay, so in order to derive the ex and ey and hx and hy, we have to take the curl of, so curl of E bar, so E bar can also be written as in terms of, so curl of E bar can be written in terms of Cartesian coordinate system as, see here, ax ay and az, so dou by dou x, dou by dou y, dou by dou z by, so ex ey and ez. Okay, so which is equals to hx ax plus hy ay, which is equals to j minus j omega mu hx ax plus hy ay plus hz az. Okay, so if ax, if you take ax in this, so we get a dou ez by dou y minus dou ey by dou z minus ay, so if we take minus ay, then dou ez by dou x minus dou ex by dou ez by dou ex by dou z plus az, if you take az as, then you will get dou ey by dou x minus dou ex by dou y, so this is x. Okay, so this is y. Okay, this is x, this is also x. Okay, so which is equals to minus j omega mu h x ax plus hy ay plus hz az. Okay, so if you equate the ax terms and ay terms and az terms on both sides, so the equation comes like this, so dou ez by dou y minus dou ey by dou z, which is equals to minus j omega hx, j omega mu hx. So which in the same form, so in the same form if you equate the ay components on both sides, so the equation comes like this. So dou ez by dou x minus dou ex by dou z, which is equals to minus j omega mu hy. Okay, so now dou ey by dou x minus dou ex by dou y, which is equals to minus j omega mu hz. Okay, so in this if you take the minus component here, so you will get this is minus and this is plus. Okay, so if I take a common on minus on both sides, so I will get a minus here. If I multiply this minus, so I will not getting here minus, so that equation can be again written. So if you consider that equation later. Okay, so these are equations obtained from this by equating these values. Okay, observe this equation, so you get dou by dou z equation value. So you already got the dou by dou z value, so which is nothing but a minus gamma. So we need to substitute the value here, so minus gamma for this equation. So I am writing the again these equations. So dou ez by dou y minus, so this is dou y. Okay, so minus dou ey by, sorry, this can be written as minus gamma ey, which is equals to minus j omega mu hx. Okay, so minus, so this can be again written as, so dou ez by dou y, so plus gamma ey, which is equals to minus j omega mu hx. So this is the equation 6. Okay, now again writing this equation now by substituting dou by dou z value is equals to minus gamma in this particular equation. Okay, so I am writing that equation. So before writing that, take a minus common on this side. So if we take the minus common, if we take a minus common, so then you will get a negative sign in the middle. Okay, so taking the second equation in this, so if you take minus common, so dou ez by dou x minus dou ex by dou z is equals to minus j omega mu hy. So here minus minus gets cancelled. Okay, now we will see. So this dou by dou z can be written as minus gamma. So dou ez by dou x minus, so minus of gamma ex is equals to, this is ex, j omega mu hy. Okay, so dou ez by dou x plus gamma ex is equals to j omega mu hy. So this is equation number 7. Now I want to write a equation number 8. So by using this, so here there is no dou by dou z value, so you can write directly. So dou ey by dou x minus dou ex by dou y is equals to minus j omega mu hz. So this is equation number 8. Okay, so after doing this, so we will take another equation for a magnetic field, so which is nothing but curl of h is equals to jd, which is nothing but a j omega epsilon e bar, j omega epsilon e bar. Okay, so by taking this equation, so you can directly, so this equation is in the Cartesian form, so you can represent j omega epsilon ex ax plus ey ay plus ez az. Okay, so now we take the curl of h bar, so which is nothing but ax ay az. So dou by dou x, dou by dou y, dou by dou z. So here hx, hy, hz. Okay, hx, hy, hz. So now write this in terms of splitting this. So I am writing here. So ax, if you take ax, so hz dou hz by dou y minus dou hy by dou z minus ay, if you take ay. Okay, so again dou by dou x of hz minus dou by dou z of hx, again plus az of, so if you take az, so you can write dou by dou x of hy minus dou by dou y of hx. So this is the curl. Okay, from this you have derived the up to curl of h bar. Okay, so you can see from this of h bar is equated to here. So this curl of h bar value is nothing but ax, so dou hx dou hz by dou y minus of dou hy by dou z minus of ay dou hz by dou x minus dou hx by dou z plus az of dou hy by dou x minus dou hx by dou y. Okay, so which is equals to j omega epsilon ex ax plus ey ay plus ez az. Okay, now equated these values so that in this ax and ax are equal, so ax components are equated in this particular equation. So dou hz by dou y minus dou hy by dou z, which is equals to j omega epsilon ex. Okay, similarly, so I can write another equation which are equated to ey and ey. So I am writing, so minus, so I am multiplying minus, so dou h by dou x, so plus dou hx by dou z, which is equals to j omega epsilon ey. Okay, so this is another equation, and the third equation can be obtained by equating the az components, so which is nothing but dou hy by dou x minus dou hx by dou y, which is equals to j omega epsilon ez. Okay, now this equation is nothing but a 9th equation, 10th equation and 11th equation. So convert these equations in terms of dou by dou z. Whenever there is a dou by dou z value, we substitute the dou by dou z value as minus gamma, so substitute that value. So dou by dou z is equals to minus gamma, so I am substituting in this particular equations. So dou by dou hz by dou y minus of minus plus gamma, so I am writing directly, so plus gamma hy is equals to j omega epsilon ex. So this is a 12a, you can written 12a equation. Okay, now you can see, so from this equation hx, so dou by dou z, so that can be again written, so dou hz by dou x minus dou hz by dou x. So here you can substitute the value of gamma, so as minus gamma hx is equals to j omega epsilon ey. So this is a 12b, and dou hy by dou x, there is no dou by dou z term, so you can write directly, so you will get a j omega epsilon ez. So this is the 12c equation. Okay, so from these three equations you can obtain the hx hy values. Okay, now to find ex value by using these equations, so take the 12a equation and substitute and find out the value of hy first. and that value is substituted in 8th equation. So from 12a equation, so take the 12a equation, dou h by dou y plus gamma hy is equals to j omega epsilon ex. Okay, so this is the 12a equation. So by using this 12a equation, you need to find out the hy value, and that hy value is substituted in 8th equation. So that substituted in 7th equation, sorry. So in the place of hy, so you will get a hy equation, and that equation is substituted here in the 7th equation, so that you will get a ex equation. Okay, now we'll see about that. Hy can be obtained as, so gamma hy is equals to j omega epsilon ex minus dou hz by dou y. Okay, so now hy is equals to j omega epsilon gamma ex minus dou 1 by gamma dou hz by dou y. So this is another equation which can be represented as 13 substitute 13 equation in 7th equation in order to get ex value, ex. So I want a ex and ey. So first we want to derive the ex value. So for that we have calculated that we have determined the hy value. That hy value is substituted in 7th equation. Now I am writing the 7th equation here again. So dou ez by dou x plus gamma ex, which is equals to j omega mu hy. So this is the 7th equation. So in this 7th equation, you need to substitute his hy value here. So dou ez by dou x gamma ex, which is equals to j omega mu hy. So j omega epsilon propagation constant gamma divided by gamma minus 1 by gamma dou hz by dou y. Okay, so now multiply this term. So dou ez by dou x plus gamma is x is equals to, so j minus omega square mu, j square is nothing but minus 1, so I am writing minus omega square mu epsilon by propagation constant gamma ex minus j omega mu by epsilon dou hz by dou y. Okay, so this is another equation. So from this equation, so you can say that, so here the ex terms are there, you can write one time on the one side, the ex terms should be right on one side. So this term is moved to this side. So and this dou ez by dou x is moved to other side. So minus dou ez by dou x minus j omega mu by gamma dou hz by dou y. So if you can take common as ex, I want ex value. So gamma plus omega square mu epsilon. So if you take gamma as an LCM, the next step you do that. Okay, so this is the value. So in the next step we take LCM on the left side of a gamma. So gamma square omega square mu epsilon is equals to dou ez by dou x minus j omega mu by gamma dou hz by dou y square. So here gamma square plus, so this is gamma, the gamma square plus omega square mu square, we have already taken that equation as a h square. So we can written ex h square by gamma, which is equals to minus dou ez by dou x minus j omega mu by gamma dou hz by dou y. So this is by using this equation we will get a ex value. So ex is equals to, so multiply this term, so minus gamma h square dou Ez by dou x minus gamma by h square j omega mu by gamma dou hz by dou y. So here gamma gets cancelled. So ex value is obtained as minus gamma h square dou Ez by dou x minus j omega mu by h square dou hz by dou y. So this is the final solution for ex value. In the same way you have to do for the hx value and ey value and hy value. Okay, to find hx we need to consider sixth equation. So the sixth equation is here. So dou Ez by dou y plus gamma ey is equals to minus j mu hx. So this is the sixth equation. So by taking the sixth equation, so you can find out the ey value, and that ey value is substituted in 12b equation, so that you will get a hx equation. Okay, so now I am noting down the sixth equation, so which is nothing but dou Ez by dou y plus gamma ey, which is equals to minus j omega mu hx. So this is the value of sixth equation. So this is the from sixth equation. So this is from sixth equation. Okay, so by taking this sixth equation you can find out the ey value. So dou Ez by dou y, which is equals to, so plus gamma ey is equals to minus j mu hx. So now I want a gamma ey, so move this term to other side, dou Ez by dou y. So ey is equals to j omega divided by gamma hx minus 1 by gamma dou Ez by dou y. Okay, so this is the value of ey, and this ey is a first, yes, that is equation number 14. You can say equation number 14. This is the equation number 14. Okay, now by using this equation ey equation, you will be substituted this equation 14. Equation 14 is substituted in 12b. So in 12b, so I am writing down the 12b equation, which is nothing but dou hz by dou x minus gamma hx, which is equals to j omega epsilon ey. Okay, so I have written here dou hz by dou x minus gamma hx is equals to j omega epsilon ey. So dou hz by dou x minus gamma hx, so we need to substitute this value in the place of here. So minus j omega mu by x gamma hx minus 1 by gamma dou Ez by dou y. Okay, so multiply these terms. So dou hz by dou x with minus gamma hx is equals to, so j into j square minus 1. So but here there is a minus, so you will get a positive value omega mu epsilon by gamma hx. So minus j omega epsilon by gamma dou Ez by dou y. Okay, so now I want a hx value, so take the hx terms on side. Dou hz by dou x, move this term to other side. So j omega epsilon by gamma dou Ez by dou y. Okay, so this is the value. So take the here hx common, so minus hx, hx common, so we'll get so take the minus hx common, so we'll get gamma square and LCM, take the LCM of gamma here. So you'll get gamma square omega square mu epsilon. So minus j omega epsilon by gamma dou Ez by dou y. Okay, so here gamma square plus omega square mu is equals to mu epsilon is equals to h square. We have already written there, so it can be written as h square by gamma dou hz by dou x minus j omega epsilon by gamma dou Ez by dou y. Okay, so now hx value can be obtained by multiplying this equation. So we'll get minus gamma by h square dou hz by dou x plus, so minus in here, this minus is multiplied here so that it will come as a plus. So by plus gamma h square multiplied with j omega epsilon gamma dou Ez by dou y. So here gamma gamma gets cancelled. So here the obtained equation as gamma by h square dou hz by dou x plus 1 by h square, which is nothing but j omega epsilon dou Ez by dou y. So this is the hx value, obtained hx value. So this is the final answer for hx. Okay, so we have calculated the ex value, and this we have calculated the hx value. In the same way you need to calculate the hy and ey also. We have derived the ex and hx. In the similar way we will derive about the ey and hy. To find ey, so let us take a 12b equation. So in order to find out this take a 12b equation. So from the 12b you need to find out the hx value. From the hx value, so from the sixth equation you can find out the, after substitution of hx value, you can easily find out the ey value from the sixth equation. Okay, so now I am writing the 12b equation. Okay, from 12b equation. So from the 12b equation, which is nothing but a dou hz minus gamma hx is equals to j omega epsilon ey. Okay, so now from this equation we will derive the hx equation, that hx is substituted in sixth equation so that ey value is obtained. So I am writing the same equation. So I want a hx value, so this dou hx by dou y can be written to that side, or you can say this is moved to this side. Okay, so the hx value can be obtained as hx is equals to minus 1 by gamma dou hz by dou x minus j 1 by gamma j omega epsilon ey. Okay, so this is the hx value, and this hx value is substituted in the sixth equation. So I am writing the sixth equation, so which is nothing but dou Ez by dou y plus gamma ey is equals to minus j omega mu hx. Okay, now this hx value is substituted here, so this equation is nothing but a 15th equation. Okay, 15th. Again I am writing the sixth equation, so this is the sixth equation, mu hx. So this is the sixth equation. So now substitute the hx value here. So dou Ez by dou y plus gamma epsilon ey is equals to j omega mu hx is nothing but 1 by gamma dou hz by dou x minus 1 by gamma j omega epsilon ey. Okay, so this is the value. So from this value you want a ey value. So dou Ez by dou y plus gamma gamma ey. So you should multiply this, value. So multiply this value. So j omega mu by gamma dou hz by dou x plus j omega mu by gamma, so j omega epsilon ey. Okay, so write the ey terms on one side and other terms on other side. So dou ez by dou y plus gamma ey, which is equals to j omega mu by gamma dou hz by dou x, so minus omega square mu epsilon by gamma ey. So move this term to this side. So I am writing the ey terms on one side. So omega square mu epsilon by gamma ey is equals to, so this term is moved to this side. So dou ez by dou y plus j omega mu by gamma dou hz by dou x. Okay, so if you take in this term as ey as common, so you'll get gamma plus omega square mu. So if you take LCM, so then we'll get like this term is like this. Okay, so minus dou ez by dou y plus j omega mu by gamma dou hz by dou x. Okay, so this can be written by, so gamma square mu omega square epsilon can be written as h square. So ey h square by gamma, so equals to minus dou ez by dou y plus j omega mu by gamma hz by dou x. So ey can be obtained as minus gamma h square dou ez by dou y plus gamma by h square j omega mu by gamma dou hz by dou x. So here gamma gets cancelled. So ey can be obtained as ey is equals to gamma by h square dou ez by dou y plus j omega mu by h square dou hz by dou x. So this is the ey equation, obtained equation. So this is the ey final value. Okay, in order to find the hy, so first you must take the seventh equation. You must take the seventh equation. Seventh equation is written here. Okay, dou ez by dou x plus gamma ex is equals to j omega mu hy. So that equation we will take. So take seventh equation. Okay, or from seventh equation. Okay, so dou ez by dou x plus gamma ex is equals to j omega mu hy. Okay, so this is the seventh equation. So from this seventh equation you need to find out the ex value, and that ex is substituted in the 12th a equation, so that you will get a hy equation. Okay, so now you will find out the ex value first. So for that, gamma ex is equals to minus dou ez by dou x plus j omega mu hy. So ex is equals to minus 1 by gamma dou ez by dou x plus j omega mu by gamma hy. Okay, so this is the ex equation. So this is the equation number 16th. Okay, so from this equation you need to substitute this equation in the 12a equation. So I am writing the 12a equation. So by using a 12a 12a equation. Okay, so dou hz by dou y plus gamma hy is equals to j omega epsilon ex. Now substitute this value of ex in this particular equation. So dou hz by dou y plus gamma hy is equals to j omega epsilon multiplied with 1 by gamma dou ez by dou x plus j omega mu by a gamma hy. So multiply these terms. Minus j omega epsilon by gamma dou ez by dou x. So j multiplication, so we'll get minus omega square mu epsilon by gamma hy. So write this term hy terms on one side. So hy gamma hy plus omega square mu epsilon by gamma, which is equals to, so minus dou h by z, move this term to this side. So minus dou h z by dou y minus j omega epsilon by gamma dou ez by dou x. So if you take this is a hy, so if you take a hy common, so I'll get and take LCM on gamma, so I'll get gamma square mu omega square mu epsilon by gamma. Okay, so and dou hz by dou y minus j omega epsilon by gamma dou ez by dou x. So you can return a gamma square plus omega square mu epsilon is nothing but a h square. Okay, now substitute the value here, h square by gamma, which is equals to minus dou hz by dou y minus j omega epsilon by gamma dou ez by dou gamma, sorry, dou x. See, this is x, dou x. Okay, now I want a hy. So from this value we'll get a hy as, so minus gamma by h square dou hz by dou y minus gamma by h square j omega epsilon by gamma dou ez by dou x. So gamma gets cancelled, so you'll get a hy as, so minus gamma by h square dou hz by dou y minus j omega epsilon by h square dou ez by dou x. So this is the hy value, obtained hy value. You can obtain, you have derived the ex, ey, hx, hy expressions. So by using this you can field patterns, you can use the t and tm mode derivations with the help of these equations. Okay, so ex, ey and hx, hy are the solutions of the field equations of a rectangular waveguide, and these are the wave equations for the rectangular waveguide. So these are you have already derived these. Okay, by using these equations we have derived the ex, ey, hx, hy equations. Okay, in this way we can get the solutions of a rectangular waveguide. This is the analysis of rectangular waveguide.